Hello guys, so welcome back to another video of AJ classes. Today we are going to discuss about how to prove that root 3 is an irrational number. So to prove root 3 is an irrational number, let us consider root 3 is a rational number. So to prove that root 3 is a irrational number, let us first consider root 3 is a rational number. So that means we can express root 3 as in the form of p by q, where q not equal to 0. So again after this, let p and q have some common factors. If they have some common factors, then dividing both p and q with their common factor or HCF, we will get root 3 is equal to a by b, where b is not equal to 0, and a and b are co-prime numbers. So now let we have that root 3 is equal to a by b. Then if you square on both the side, we will get 3 is equal to a square by b. This is a square by b square. This implies that 3b square is equal to a square. That means 3 divides a square. That means if this is square, 3b square is equal to a square, that means this a square is divisible by 3. That means 3 divides a square, and according to the 3 theorem, that is 3 also divides a. So let consider a is equal to 3c, that all 3 divides a. Let us now consider that a is equal to 3c. Putting the value of a in, let we consider this as equation 1. Putting the value of a in equation 1, what will we get? That 3b square is equal to 3c whole square. This implies that 3b square is equal to 9c square. This implies that b square is equal to 3c square. That means 3 divides c square. This implies 3 also, according to the theorem, 3 also divide c. That means from here we can see that we get in the first case 3 divides a, and here we get, this is b square and this is b. 3 also divides b square and 3 also divides b. That means a and b have common factor. A and b have common factor 3, but this contradicts the fact that a and b are co-prime. Thus our assumption is wrong. Hence root 3 is a irrational number. Here you can see the total proof. In the first case, what we are doing, first we have given that we have to prove that root 3 is irrational number. So let first we consider that root 3 is a rational number. Then after that we know that the rational numbers can be expressed in the form of p by q. So let me express root 3 is equal to p by q, where q is not equal to 0. Let there may be possible that p and q have some common factors. That's why we are dividing that p and q with their highest common factor, and we will get root 3 is equal to a by b, where b is not equal to 0 and both a and b are co-prime. Co-prime number means they have no other common factor than 1. So let we have taken this root 3 is equal to a by b. Now squaring on both sides, we will get 3 is equal to a square by b square. Then by cross multiplying, 3b square is equal to a square. This means this 3 is a factor of a square, that means 3 divides a square. And according to the theorem, that 3 will also divides a. If a number divides its square, then the number will also divide the number itself. Then now let us consider a is equal to 3c, a constant multiplied with 3, as 3 divides a, that will a will be a multiple of 3. Now putting the value of a in equation 1, you will get that instead of a we will write 3c whole square, that is 3b square is equal to 9c square, that is b square is equal to 3c square. That means that 3 divides b square and 3 also divides b. And here a and b have common factors 3, but this contradicts to the fact that a and b are co-prime. From here these two lines, what we will get, that one we get 3 divides a and another get 3 divides b. That means 3 divides both a and b. That means 3 is a common factor of both a and b. But we have get here that 3 is a co-prime number. That contradicts our assumptions. That's why our assumption that root 3 is a rational number is wrong. Therefore root 3 is a irrational number. I think you understand this very well. If you like the lecture, then like the video and subscribe the channel for more videos. Thank you.